Have you ever wondered how you can prepare for a calculus exam? In this video, we will solve the main kind of questions that you expect to see step by step. And I will show you the exact method that you need to use and why they should work. So let us begin by a U substitution kind of problem. So here we have the integral of 3x over x squared plus 3 dx. Then I can write this by factoring out the 3 here because 3 is a constant, right? So I take out 3 here and write the integral of 1 over x squared plus 3 x dx for a reason, okay? So we know that, the derivative of x squared plus 3, right? The derivative of x squared plus 3 is just 2x, okay? And you can see that you have x in the numerator here. So it is essential that we make u to be equal to x squared plus 3. And this gives us what? The derivative of u is equal to 2x dx, okay? Now that we have du is equal to 2x dx, you can see that here I wrote x dx, right? Which is this x dx. So for this to be the same, I just need to divide throughout by u, okay? So this implies that du over 2 is equal to x dx. So I meant dividing throughout by 2 so that I have x dx, okay? So where there is x dx, I just substitute. I just plug in du over 2, and where there is x squared plus 3, I plug in u. So the integral becomes what? The integral just becomes 3 over 2, right? 2 which is coming from here. Then this is the integral of 1 over u. Where there is x squared plus 3, I put u. Then where there is x dx, that is du, right? Du, okay? I just wrote 1 over 2 on the first side, okay? But we know what the integral of 1 over u is from the integral table. Is just the natural log, right? So this is 3 over 2 natural log of, you can write the absolute value of u, then plus the constant of integration. But we know what the value of u is, right? So we can write this as x squared plus 3, then plus c, okay? So here I just write in parentheses and forget about the absolute value because x squared plus 3 will always be positive. To evaluate this integral, we can do the same thing, right? So let me say u to be equal to x squared plus 11, so that the derivative of u is equal to 2x du, okay? But we already have 2x in the numerator. We have 2x dx, which is this 2x dx, which will be our du, right? So our integral will just become, so this is just the integral of 1 over u with respect to u, which is just what? The natural log of the absolute value of u plus c. But we know the value of u, so we just substitute this is the integral of, the value of u is x squared plus 11. Then we add our c. In this problem, we have the integral of 3x to the power 4, then we have the exponent, this exponential to this exponent. So you can see that the exponent in the exponential function has a power 5, and the function that you're multiplying with has to the power 4, okay? So this exponent on the exponential function, when we take the first derivative, it loses 1 power, right? Which is to the power 4, okay? So it is very important that we can make our u to be equal to 3x to the power 5 plus 4, okay? You see why we made u to be equal to that. So that when we take the derivative of u, we just find what? This is 15 x to the power 4 dx, okay? But in the problem here, we already have 3x to the power 4 dx, so we can just divide throughout by 5, right? So that we have divided by 5, okay? So that we just write this as du over 5 is equal to 3x to the power 4 dx, okay? So I just wrote this 3x to the power 4 dx because I already have in the integral, so that our integral just becomes the integral of, I write 1 over 5 outside, then the exponent, I write exponential u, right, with respect to u. And from the integral table, this is just 1 over 5 e to the power u plus c. Okay, but we know what the value of u is. So this is just 1 over 5 e, then 3x to the power 5 plus 4, then plus c. This is a trigonometric integral. So in this question, you can observe that the cosine power is odd, right? Because this is just 5, okay? So what we can do, we can save one factor of cosine. So that is why we write sine to the power 4x, then cosine to the power 4x, I multiply by cosine x dx. So I've not changed anything here, right? Instead of writing cosine to the power 5, I write cosine to the power 4 multiplied by cosine x dx, okay? Next, we are going to take a note here. The note that we take is that the cosine squared of x is equal to what? 1 minus sine squared x. So this is a fundamental identity that we should know. Next, we are going to write this cosine to the power 4x. I can write it as in cosine squared x, and then I take the square outside. Okay, so you know that 2 and the 2, it's 4, right? But you know that what cosine squared x is, so we can just do the substitution. 1 minus sine squared x, then I square this. Okay, now at this stage don't rush to expand, right? So let us just do the substitution in our integral. So our integral becomes the integral of sine 4x, then where there is cosine to the power 4x, I put what we found here. So this is 1 minus sine squared x to the power 2, right? Then remember we have cosine x with respect to x. Now we can go ahead and make the u substitution. So the choice of u here obviously is what? Is sine, right? So let u to be equal to sine x. Okay, so this implies that what? This implies that du is equal to cosine x dx. Okay, so where there is cosine x dx here, remember we saved our cosine, right? So where there is cosine x dx, we just put du. So therefore the integral becomes integral of, where there is u we put, where there is sine we put u. So this is u to the power 4, then 1 minus u squared, then du. Okay, so inside is just simple algebra. We can do the expansion. So when we expand this, you should get u to the power 4, then minus 2 u to the power 6 plus u to the power 4, okay, with respect to u. So we can go ahead and integrate this. So this is just 1 over 5 u to the power 5, then minus, I can write this 2 over 7 u to the power 7, then plus this should be 8 here, right? So 1 over 9 u to the power 9, then plus c. I write this as sine to the power 5x over 5, then minus 2 sine the power 7x, everybody over 7, then plus sine the power 9x, everybody over 9, then plus c. So that should be our final solution. Now this is a very simple problem. So we use just this trig identity. So we know that sine squared x is given by this expression 1 minus cosine 2x divided by 2. Okay, so we just do the substitution. So our integral becomes the integral of what? That is just 1 minus cosine 2x, everybody over 2, then this with respect to x. Okay, so I can write this as the integral of 1 over 2 minus cosine 2x, everybody over 2, this with respect to x. But this should be very simple. This is just the integral of half. It will just be 1 over 2, then minus, cosine. The integral of cosine is what? Is sine, right? But there is a 2 inside, so we drop the 2. So this becomes 1 over 4. Then this is sine 2x, then plus c. Okay, for this integral we use integration by parts. So you know that integration by parts depends on this method, right? So linearity means you look for logarithmic expression, right? If they are logarithmic expression, they should be given a first priority. Then I is for inverse trig, then A is for algebraic expression, T is for trigonometry, then E is the exponential function. So in this case, because algebraic expression has the higher order, right? In this case, so we start with we make u to be equal to 3x. Okay, so let us do u to be equal to 3x. This implies that what? Du is equal to 3 dx. Okay, then we can take our dv to be equal to e to the 2x with respect to x. Then we can integrate both sides here so that v is 1 over 2 e to the 2x. Okay, then we can go ahead and substitute into our formula. So u is 3x and we have 1 over 2, so we can just write 3 over 2. I write x, then e to the 2x minus du is 3 dx, so I write this 3 over 2 from v. Then this is the integral of e to the 2x with respect to x. Now we can go ahead and finish this up. So this is x, e to the 2x, then minus, so the integral of e to the 2x is what? Is 1 over 2, right? So this becomes 3 over 2, then e to the 2x, everybody plus c. Okay, so if you want, you can make this to look more nicer. I mean, this one was 3 over 4. If you want to, we can make this to look more nicer by factoring out 3 over 4. 3 over 4, I factor out e to the 2x. Okay, so in the first expression, if I factor out 3 over 4, I would need 2 inside x, right? Because 1 over 4 multiplied by 2 is 1 over 2, which is outside. So I have 2x inside, then minus 1. Everybody has gone outside, then plus c. Okay, that is the simplified version. In this problem, again, remember the integral of u dv is equal to uv minus integral of v du. And we said we use this, right? So in this case, we have L here, logarithmic expression, has higher order. So we choose u to be the natural log of u. We choose u to be the natural log of x. So u is equal to natural log of x. This implies that du is equal to the derivative of natural log of x is 1 over x, then dx. Okay, then let us choose our dv to be equal to 4x dx, right? So which implies our v here is just what? 1 over 2, so this becomes a 2x squared. So applying our integration by parts formula, let us substitute our u, right? So this becomes a 2 outside, then x to the power 2 natural log of x, then minus the integral of v is what? V is 2x squared, so I can write the 2 outside. Then I write this x squared, but remember there is 1 over x dx, right? Because our du is 1 over x dx. So I write it like that. Then I can just simplify one more step before I integrate. So this is 2x squared natural log of x minus 2 outside. You know, x into x squared, we remain with x. So this is x dx. Then we can do the integration. This is 2x squared natural log of x minus what? X squared over 2, but there is 2 outside, so this just becomes x squared. Then plus our c, integration constant of integration. Actually, for this problem, we are not going to write the full partial fraction decomposition of this expression, right? The idea is just to introduce the notion of how we decompose partial fractions. So what is very important here is that we write the denominator, which is x squared, x to the power 4 minus 1, you know, as a product of its factors. Okay, so you can see here that we have, let me just say factors here. Okay, so you can see that here we have what? We have x, right? So we can write this as x. We have x here goes into that, then we have x squared, and then we have x to the power 4 minus 1. But now I need to work on x to the power 4 minus 1. So let us go ahead and write x to the power 4 minus 1 to be equal to, I can write x to the power 2, then everybody raised to the power 2 minus 1. Okay? By the difference of two squares, if we have a squared minus b squared, this is just same as a plus b, then a plus c. Okay, so take your a to be x squared and to b as 1. So I can just write this as an x squared minus 1 or plus 1, then x squared minus 1. Then we can do something again here, because this goes to where? X squared plus 1, you know, it cannot be reduced any further, but on x squared minus 1, I can write it as an x plus 1, then x minus 1. Okay, so if we are setting up this as a partial fraction decomposition, this becomes, so we have a over the first factor is x right here, then plus b over the second factor is x squared, then plus c over, now let me go ahead and take, you know, x plus 1, then I also take let me say d over, let me say x minus 1. Then the last one is for the quadratic factor, because I have a quadratic factor, so this will be a, b, c, d, I would say ex, you know, plus f, right? Just write another letter, then x squared plus 1. Okay, so if you are decomposing this, the setup of this will be like that. So normally this kind of problem will come as a multiple choice. They will say, what is the setup of the partial decomposition of this kind of expression? So this should be your answer. So in this problem, we have x squared plus 3x plus 4, everybody divided by x plus 1. So you can see that the degree of your variable in the numerator is greater than the degree of the variable in the denominator. So we have to decompose this into a smaller fraction, right? We have to divide this. So you can use long division. So when you use long division, you'll find that this is equal to x plus 2, right? Then plus 2 over x plus 1. Our integral becomes this is the integral of this whole expression, x plus 2 plus 2 over x plus 1. This is with respect to x. Okay, so again, x, the integral of x squared, this is just x squared over 2, then plus, this is 2x, then plus. So here we can just factor out the 2, and the integral of 1 over x plus 1 is just the natural log, right? Natural log of x plus 1. This is plus c, okay? So remember how you find that integral. So this is the end, right? But let me just make a note here. So let's say for the integral of 1 over x plus 1, right, with respect to x. So remember, you would do your u, let u to be equal to x plus 1. So this implies that du is equal to dx. Okay, so where there is x plus 1, I put u. So this is the integral of 1 over u. Dx, we say it is du. And this is just the natural log of, u plus what? Plus c. Okay. But we know what u is here. So we have natural log of x plus 1 plus c. Okay, but in this case, x plus 1 can be negative, so that is why we have to maintain, absolute value sign. So this should be absolute value. This problem is an application of L'Hopital's rule. So you can see that here when we have the limit as x goes to infinity of the square of x. So here as x goes to infinity, the square of x here goes to what? Goes to infinity. Okay, then multiply by the e to the negative x as x goes to infinity also goes to what? This one goes to 0, right? Because it goes smaller and smaller. Okay, so this is indeterminate. Okay, so what we can do here, we can write this as the limit as x goes to infinity, right? Then let's write this as the square of x, then divided by, so I bring the negative, right, using just laws of indices. This is e to the x minus 2. Okay, so again, in the same way here, if we try to use the direct substitution, this goes to what? Infinity over infinity, right? So which is indeterminate. So what we can do, we can just take the derivative of both the numerator and the denominator, right? So this is just the same as the limit as x goes to infinity. Then the derivative of the square root of x is just what? 1 over 2. Then 1 over the square root of x, right? Then divided by, this will just be, 1 over 2, then e to the x over 2. Okay, so obviously 1 over 2 and 1 over 2 cancels. So you can see that this simplifies to the limit as x goes to infinity. So the fraction here, we can multiply both the numerator and the denominator by the square root of x, so that this is just 1 over the square root of x, then e x over 2. Okay, so as x goes to infinity, the denominator goes to infinity, so this thing goes to 0. Okay, because you have 1 over a big number, which is 0. Let us determine whether this integral converges or not. Okay, so the interest is not finding the value of this integral, is to see whether it converges or not. So obviously you can see that x to the power 3 is less than x to the power 3 plus 5. Okay, for example, if x is 0, this is just 0 less than 5. That holds, right? So if this is the case, because this x plus x to the power 3 plus 5 is bigger, when we take the reciprocal, it will come in the denominator, x plus 3 plus 5, right? Then this will be less than 1 over x to the power 3. Okay, so meaning that this integral, the integral that is in question, is comparable to the integral from 1 to infinity of 1 over x to the power 3. Okay, with respect to x. But this integral that I've just written here, right? This integral converges because it is a p integral. This is a p integral with the value of p to be equal to 3. So therefore we conclude that, so if you're writing in an exam question, you can say therefore you conclude by, by comparison that this integral that is in question also what? Converges. So this question is about finding the area between two curves. So there is a region that is bounded by this function f of x equal to negative x squared plus 4 and h of x equal to 3x and the y-axis. Okay, so the first thing is to find the intersecting points, right? So between f of x and h of x, so where do they meet? So these two functions, they meet when negative x squared plus 4 is equal to 3x. Okay, so this becomes x squared upon multiplying it by negative, then plus 3x, then minus 4. Okay, 3x is positive because it was multiplied by a negative, right? So this is equal to 0. Next, we can just solve this. So I need two numbers such that their sum is 3 and their product is negative 4. So obviously I need 4 minus 1, right? So plus 4 and minus 1. So therefore x is equal to 4 and x is equal to 4 as negative and x is equal to 1 positive. To kind of have a visualization of this graph, I draw the curve. So you can see this parabolic curve here is the graph of y is equal to x squared plus 4, and the straight line is the graph of y is equal to 3x. So because the question says you want the region that is bounded by the parabola, the straight line, and the line y is equal to, the x-axis. So the y-axis, and this is the y-axis here. So you have this line here for the parabola and the inner line. So that is why the region here, the white shaded region, is the area that we want, right? And this area is just between 0 to 1. So that is why in our area here, you can see we're integrating from 0 to 1. And because the quadratic function is above the linear function, we write negative x squared plus 4 minus 3x with respect to x. Then we can just integrate with respect to x and plug in our limits from 0 to 1. Okay, so when we plug in 1, we just get negative 1 over 3 plus 4 minus 3 over 2, then minus 0, right? When we plug in 0, everybody is 0. Okay, then if you want, you can make these equivalence fraction, because the denominators, we have 3 and we don't have anything here. So 3 multiplied by 2 is a 6, so we can multiply this by 2 and this by what? And this by 2, that is a 6, and then 4 by 6 is 24, so this is just 24 divided by 6, and then this is 3 divided by 3, okay, which is a 6. So negative 2 plus 24 minus 9 should give us 13. So in this problem again here, remember we sketched the graph of h of y is equal to y, right? So if this is the case, then it means x is equal to y in this case, right? X is equal to y, where there is h I put x, and the other one x is equal to the square root of y. Okay, so the same way you draw the graph of y is equal to the square root of x, but this is flipped, right? That is why it is facing up like that. Okay, but that is not our interest. Our interest, we just wanted to see where the region is. So that is from 0 to some point here, which we need to determine. So to determine the intersecting points that are set to root y is equal to y, then we can square both sides, so that for y is equal to y squared Then we can write this as in y squared minus 4y is equal to 0. Then let's go ahead and factor out y minus 4 is equal to 0. So this tells us to say y is equal to 0 or y is equal to 4. Okay, so we are integrating from 0 to 4. So we have the integral from 0 to 4. And from the graph, remember this is x is equal to y, so we say right, x right minus x left. So the one that is on the right side is the square root function, and on the left side the linear function. So this is 2 the square root of y minus y with respect to x. Okay, so this is just 2. This is just 2 outside, then multiply by 2 over 3, because on half, when we add 1 we get 3 over 2. Then minus 1 over 2 y squared, and our limits are from 0 to 4. Okay, so when you plug in your limits, minus 0 because that is just 0, and when you simplify this you should be able to get 8 over 3. Okay, so I leave it as an exercise to simplify what is in this expression.